Now, in this lecture, we'll find out the length of line segment X. In the drawing, we have a quarter circle. A or B is a quarter circle. Inside this quarter circle, we have a semicircle. This is a semicircle. In addition, we know that line segment AO equals to 10 units in its length. And our mission is to find out the length of this line segment AM, that's equal to X according to what is given us in the question. So first of all, AOB is a quarter circle, therefore this angle AOB is a right angle, is equal to 90 degrees in its size. And also side AO equals to side OB. They are both the radii of this quarter circle, therefore they are equal to each other. But we know that AO equals to 10, therefore OB must be also equal to 10 units in its length. OB equals to 10. OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. Okay, so OB equals to 10 units, and it is the diameter of this semicircle. We define the center of this semicircle, this point as P. The radius OP of the semicircle equals to the diameter over 2. The diameter is 10, and therefore the radius is 10 over 2, that is 5. So OP equals to 5 units. The radius PB also equals to 5 units in its length. We define the point of tendency of tangent AM with this semicircle as point Q. And we join points P and Q together by a straight line. Point P is the center of the semicircle. Point Q is the point of the semicircle itself. Therefore, PQ is the radius of this semicircle. Therefore, it is equal to 5 units in its length. Okay, so we'll extend side OB and side AM by a straight line until they touch each other. And we define the touching point of the extended line segment OB and the extended line segment AM as N. By doing this construction, we created here the right triangle AON. In the right triangle AON, we will define this angle ONA as theta. And we will continue to focus on the right triangle AON. In the right triangle AON, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we will focus on the green right triangle QPN. In the green right triangle QPN, here we actually have, before we will focus on the right triangle QPN, we will implement rule number 1. According to rule number 1, we have the radius PQ that is drawn to point Q, that is the point of tendency of tangent AM, with this semicircle, and whenever your radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. Here we focus at point A. From point A, we have two tangents to this semicircle, tangent AO and tangent AM. And according to rule number 2, the lengths of two tangents from a common extent point to a circle are equal. That is to say, AO equals to AQ. But AO is 10, therefore AQ must be also equal to 10 units in its length. Now we will focus on the green triangle PQN. In the green triangle PQN, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. In order to complete the sum of the angles in this right green triangle to 180 degrees, the missing angle here must be equal to 90 degrees minus theta. In the next step, we prove that the right big triangle AON is similar to the green right triangle PQN. So write it down. Repeat again, we prove that the right big triangle AON is similar to the right green triangle PQN. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle AON in the right triangle AON, and it is equal to this angle in the green triangle. This is actually angle PQN. Repeat again, angle AON in the big right triangle AON equals to angle PQN in the green right triangle PQN. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. If we relate to angle theta as it belongs to the big right triangle AON, it will be defined as angle ANO. And it is equal to itself. So if we define angle theta as it is, if we relate to angle theta as it belongs to the green triangle, it will be defined as angle QNP. Repeat again. This equation means that angle theta equals to itself. Just call to angle theta two different names. Angle theta is an angle that belongs to both triangles. And finally, those two angles they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle OAN in the big right triangle AON, and it is equals to this angle, this is actually angle QPN in the green triangle. Repeat again. Angle OAN in the big right triangle AON equals to QPN in the green triangle. They're both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the big right triangle AON are correspondingly equal to all the three angles in the green right triangle QPN. Therefore we proved actually that the green triangle AON is similar to the green triangle QPN according to angle similarity rule. So I write it down. The green, the big right triangle AON is similar, this is the sign of similar, to the green right triangle PQN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AO in the big triangle AON over side QP in the green triangle equals to side AN in the big right triangle AON over side PN in the green triangle. Repeat again. We derive that AO over QP equals to AN over PN, and it is also equals to side ON in the big right triangle AON over side QN in the green triangle. Okay. And it is also equals to side ON over side QN. So here AO is 10 units over QP is 5, and it is equals to AN. What is the length of AN? From the law it is very easy to see that AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10 plus QN. So AN equals to 10 plus QN, here AN equals to 10 plus QN over PN. What is the length of PN? From the domain it is very easy to see that PN equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. Here, PN equals to 5 plus BN, and it is also equals to ON. What is the length of ON? ON equals to OP plus PB plus BN. That is to say, ON equals to OP, that is 5, plus BB plus PB, that is also 5. 5 plus 5 is 10, plus BN. So in total, ON equals to 10 plus BN. Here, ON equals to 10 plus BN. divided by Qn. Qn is the missing side, so we leave it as it is. In conclusion further, that 10 over 5 equals to 10 plus Qn over 5 plus Bn, and it is also equals to 10 plus Bn over Qn. 10 over 5 is 2, so 2 equals to 10 plus Qn over 5 plus Bn, and it is also equals to 10 plus Bn over Qn. So those two sides are equal to each other, therefore we create the equation number 1 from those two sides that are equal to each other. So according to equation number 1, we'll get that 2 equals to 10 plus Qn over 5 plus Bn. Repeat again, according to equation number 1, equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other, therefore we create the equation number 2 from those two sides that are equal to each other. So according to equation number 2, equals to 10 plus Bn over Qn. Repeat again, according to equation number 2, 2 equals to 10 plus Bn over Qn. So here we multiply this equation number 1 by 5 plus Bn. And we get that according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Here we'll open the brackets on this side of equation number 1. And we get that 2 times 5 is 10, plus 2 times Bn is 2Bn. That is equals to 10 plus Qn. So here we have 10 on both sides of the equation, so 10 we get cancelled, and we're left only with Qn that is equals to 2 times Bn. This is according to equation number 1. Here we multiply this equation number 2 by Qn. And we get that according to equation number 2, 2 times Qn equals to 10 plus Bn. Repeat again, according to equation number 2, 2 times Qn equals to 10 plus Bn. Now we can substitute Qn in this equation number 2 by 2 times Bn from equation number 1, because Qn equals to 2 times Bn. We'll do it now, and we'll get that according to equation number 2, 2 times Qn, and Qn according to equation number 2 is 2 times Bn, is equals to 10 plus Bn. So 2 times 2bn is 4bn. So 4bn equals to 10 plus bn. Here we subtract bn from this equation number 1. And we get it from this equation number 1. 4bn plus bn is 3bn, so 3bn equals to 10. Here we divide this equation number 1 by 3. And finally we get that bn equals to 10 over 3 units instead. So bn equals to 10 over 3. We write down in the original drawing that this 9 segment bn equals to 10 over 3 units instead. According to equation number 1, we have already found out that Qn equals to 2 times Bn. So Qn equals to 2 times Bn. Bn is 10 over 3, so it is 2 times 10 over 3. So Qn equals to 2 times 10 over 3, that is 20 over 3. So conclusion found out that Qn equals to 20 over 3. Again, this nine segment Qn is equals to 20 over 3 units in its length. In the next step, we complete the quarter circle to a circle. So we completed the quarter circle to a circle, and we extend 9 segment BO by a straight line until it touches the circle. And we define the touching point of the extended 9 segment BO with this circle is C. Point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of this circle. The radius of this circle equals to 10 units because the radius of the circle and the radius of the quarter circle are the same, and we already found out that the radius of the quarter circle equals to 10 units in its length. We just completed the quarter circle to a circle, therefore the circle and the quarter circle have the same radius, therefore the radius of the quarter circle and the radius of the circle equals to 10 units in its length. In the next step, I present to you a new rule, and we implement the new rule in our drawing. The new rule is rule number 14. According to rule number 14, in any circle, if you draw two chords A, B and C, D in the circle from the common external point P, then the following equation will be true, that PA times PB equals to PC times PD. So we have here a circle, and here we have the common external point P. From the common external point P, we draw two chords inside this circle, chord AB and chord CD. Both those two chords are drawn from point P inside this circle. So in this drawing, the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. You can actually implement rule number 14 in our drawing. Why? Because in our drawing, if we focus on the common external point N, from the common external point N, we have two chords inside this circle called MA, and the second chord is called BC. So all the requirements of rule number 14 are met. Therefore, according to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. So I write it down. According to rule number 14, if you focus on the common external point N, NB times NC equals to NM times NA. Again, if you focus on the common external point N, according to rule number 14, NB times NC equals to NM times NA. So first of all, we find out the length of line segment NM. From the drawing, it is very easy to see that NM equals to QN plus QN. Repeat again. NM equals to QN plus QN. NM equals to QN minus QM. So NM equals to QN. QN is 20 over 3 minus QN. So in conclusion, found out that NM equals to 20 over 3 minus QM. Now we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. So here NB is 10 over 3. So we substitute NB by 10 over 3 times NC. What is the length of NC? NC is Cn. So what is the length of Cn? Cn equals to CO plus OP plus PB plus Bn. That is to say, Cn equals to CO, that is 10, plus OP, that is 5, plus PB, that is 5. 10 plus 5 plus 5 is 20, plus Bn, that is 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Here, Cn is NC, it is equals to 20 plus 10 over 3. And it is equals to Nm. Nm, result right now found out that Nm equals to 20 over 3 minus Qm times Na. What is the length of flight segment Na? Na is An, so An equals to AQ plus Qn. That is to say, An equals to AQ, that is 10, plus Qn, that is 20 over 3. So in total, An equals to 10 plus 20 over 3. So we actually found out that 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we will divide this by 3 in order to have a common factor with 10 over 3. 10 times 3 is 60 and 60 plus 10 is 70 divided by 3. And it is equals to 10 over 3 minus Qm. Here multiply minus Qm by 3 and then we divide it by 3 in order to have a common factor of 20 over 3. So in the numerator we have 20 minus Qm times 3 is minus 3 Qm. So in total, in the denominator of this expression, we have 20 minus 3 Qm divided by 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor of 20 over 3. So 10 times 3 is 30 and 30 plus 20 is 50. So in total, in the denominator of this expression, we have 50 divided by 3. Here, on both sides of the equation, we have 9 in the denominator, so we multiply the equation by 9 in order to cancel the denominator 9. And we get that after we multiply this side of the equation by 9, we left only with 10 times 70, and it is equals to, after we multiply it by 9, this side will be, we'll have only left only with 20 times 3 Qm times 50. Repeat again. After we multiply the equation by 9, we're left only with 10 times 70. This is equals to 20 minus 3 qm times 50. Here we'll divide this equation by 10. And you get that 10 over 10 is 1, so here we're left only with 70. This is equals to 10 minus 3 qm times 50, and 50 over 10 is 5. So here we'll open the brackets on this side of the equation. We'll get that 70 equals to 5 times 20 is 100 minus 3 qm times 5 is minus 15 qm. Here we subtract 70 from this equation, and we get that 70 minus 70 is 0, and it is equals to 100 minus 70 is 30 minus 15 qm. Here we will add 15 qm to this equation, and we will get that 15 qm equals to 30. Here we divide this equation by 15, and we get that qm equals to 30 over 15 is 2, so qm equals to 2 units in its length. So here, this line segment QM equals to 2 units in its length, so I write it down in the original drawing here. QM equals to 2 units. Our mission is to find out the length of this line segment AM, that is equal to x according to what is given us the question. Repeat again, we have to find out the length of line segment AM, that is equal to x, and from the drawing it is very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. So here AM equals to AQ plus QM. AQ is 10 and QM is 2. So in total AM equals to 10 plus 2, that is 12. In conclusion, we found out that X, that is equals to AM, is actually equals to 12 units in its length. And that is the answer to our question. Repeat again. If this line segment AM that is equals to X, it is equals to 12 units in its length. Okay, so in the next step, I'll summarize the lecture. In this lecture, we found out the length of this line segment AM, that is equal to x according to what is given as the question. Here AM equals to x. So in the drawing we have a quarter circle. This is a quarter circle. Inside this quarter circle we have this semicircle. And we know that this side AO equals to 10 units in its length. Again, our mission is to find out the length of this line segment AM, that is equal to x, according to what is given as the question. So first of all, we know that AOB is a quarter circle. Therefore, this angle AOB is a right angle. It must be equal to 90 degrees. And side AO and side OB, they are both the area of this quarter circle, therefore they are equal to each other. But it is given as the question that AO equals to 10, therefore OB must be also equal to 10 units in itself, because it is also the radius of this quarter circle. Okay. OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So we know that the diameter of this semicircle equals to 10 units in length. We define the center of this semicircle, this point is P. So the radius PO must be equal to 10 over 5. The radius PO must be equal to 10 over 2, that is 5. Here PB, it is also the radius of this semicircle, therefore it is equal to 5 units in its length. We define the point of tendency of tangent AEM with this semicircle as Q. Then we join points P and Q together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle, therefore it is equal to 5 units in its length. We have the radius PQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever we have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP according to rule number 1. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then we focus on the common external point, point A. From the common external point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, they are equal to each other. That is to say, AO equals to AQ. But AO is 10, therefore AQ must be also equal to 10 units in its length. Then we extended line segment AM and line segment OB by straight line until they touch each other. They touch each other here, so we define their touching point. This point is point N. By doing this construction, we created here the right triangle AON. In the right triangle AON, this angle equals to 90 degrees. We define this angle as angle theta. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Okay. Then we focused on the green right triangle QPN. In the green right triangle QPN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. According to the same logic, that this angle equals to 90 degrees minus theta. Then we proved that the green triangle QPN is similar to the big right triangle, triangle AON. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. And finally, this angle, those two angles also equal to 90 degrees, each of them equals to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the triangles of the right big triangle AON are correspondingly equal to all the triangles of the green triangle, triangle QPN. Therefore, we actually proved that the right big triangle AON is similar to the green triangle QPN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10, QP is 5, and it is equals to AN. What is the length of AN? From the drawing, it is very easy to see that AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN. Here, AN equals to 10 plus QN over PN. What is the length of PN? PN equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. Here, Pn equals to 5 plus Bn, and it is equals to On. What is the length of On? From the drawing, it is very easy to see that On equals to OP plus PB plus Bn. That is to say, On equals to OP, that is 5, plus PB, that is also 5. So 5 plus 5 is 10, plus Bn. So in total, On equals to 10 plus Bn. It again, On equals to 10 plus Bn over Qn. Qn is the missing sign, so we leave it as it is. Here 10 over 5 is 2, so 2 equals to 10 plus Qn over 5 plus Bn, and it is also equals to 10 plus Bn over Qn. So, those two sides are equal to each other, therefore we created the equation number 1 from those two sides that are equal to each other. Those two sides are also equal to each other, therefore we created the equation number 2 from those two sides that are equal to each other. So actually, those are the two equations that we created from the long equation. If we multiply this equation, equation number 1 by 5 plus Bn, and found out that according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Here we open the brackets on this side of this equation. Equation number 1, we found out that 2 times 5 is 10, plus 2 times Bn is 2Bn equals to 10 plus Qn. Here we have 10 on both sides of this equation, equation number 1, so 10 will get cancelled. We left only with Qn, that equals to 2 times Bn. Here we multiply this equation, equation number 2 by Qn, and found out that 2 times Qn equals to 10 plus Bn. According to equation number 2, 2 times Qn equals to 10 plus Bn. So we actually can substitute Qn in this equation, equation number 2, by 2 times Bn from equation number 1. Because Qn equals to 2 times Bn. We did it and found out that according to equation number 2, 2 times Qn. And Qn is 2 times Bn equals to 10 plus Bn according to equation number 2. So 2 times 2Bn is 4Bn, so 4Bn equals to 10 plus Bn. Here we subtracted Bn from this equation, equation number 2, and found out that 4Bn was Bn is 3Bn, so 3Bn equals to 10. Here we divided this equation, equation number 2 by 3, and finally found out that Bn equals to 10 over 3 means its length. Here this side 7Bn equals to 10 over 3 means its length. This is according to equation number 2, while according to equation number 1, we have already found out that Qn equals to 2 times Bn. So that is to say Qn equals to 2 times Bn, and Bn is 10 over 3. So Qn equals to 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So we already found out that Qn equals to 20 over 3 units in its length. This line 7 Qn, it is equals to 20 over 3 units in its length. Then we completed this quarter circle to a circle, and we extended line segment BO by a straight line until it touches the circle. At this point, we define the touching point of the extended line segment BO if this circle is C. Then I presented to you all number 14, and we implemented all number 14 in our drawing. According to all number 14 is true in any circle. So in any circle, if we draw two chords A, B, and C, D inside the circle, from the common start point, point P, then the following equation will be true, that PA times PB equals to PC times PD. So we have here this circle and the common start point, point P. From the common start point, point P, we draw two chords inside this circle. This is called AB, and the second chord is called CD. Both of them exiting from this common start point, point P. So in this drawing, the following equation will be true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. You can implement all number 14 in our drawing. Why? Because in our drawing, we have the common start point, point N. From the common start point, point N, we have two chords inside this circle. We have chord MA, and we have also chord BC. Both of them exiting from the common start point, point N. So all the requirements of rule number 14 are met, therefore we can implement the rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Repeat again. According to, if we focus on the current point N, according to rule number 14, NB times NC equals to NM times NA. Then we calculated the length, we found out the length of this line segment NM. From the domain itself, it is very easy to see that NM equals to Qn minus Qm. Again, NM equals to Qn minus Qm. Repeat again. NM equals to Qn minus Qm. Qn is 20 over 3, so NM in total equals to 20 over 3 minus Qm. Then we return to this rule number 14. According to rule number 14, NB times NC equals to NM times NA. NB is 10 over 3 times NC. NC and Cn are the same, so Cn in total equals to CO plus OP plus PB plus Bn. That is to say, Cn equals to CO that is 10 plus OP that is 5 plus PB that is 5. 10 plus 5 is 20 plus Bn that is 10 over 3. So in total Cn equals to 20 plus 10 over 3. Here Cn equals to 20 plus 10 over 3 and it is equals to Nm. We just right now found out that Nm equals to 20 over 3 minus Qm times Na. What is the length of this line segment Na? Na and An are the same. An equals to Aq plus Qn. That is to say, An equals to Aq that is 10 plus Qn that is 20 over 3. So in total, An equals to 10 plus 20 over 3. Yeah. An equals to 10 plus 20 over 3. So if we found out that 10 over 3 times 20 plus 10 over 3. Here we multiplied 20 by 3 and then we divided by 3 in order to overcome factor with 10 over 3. And found out that 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator of this expression we have 70 divided by 3 and it is equals to 20 over 3 minus Qm. Here we multiplied minus Qm by 3 and we divided by 3 in order to overcome factor with 20 over 3. So in total, the numerator of this expression we have 20 and minus Qm times 3 is minus 3 Qm. So in the numerator in total, we have 20 minus 3 Qm divided by 3 times 10 plus 20 over 3. Here we multiplied 10 by 3 and then we divided by 3 in order to overcome factor with 20 over 3. And found out that 10 times 3 is 30 and 30 plus 20 is 50. So in total, in the numerator of this expression we have 50 divided by 3. Here on both sides of the equation, in the denominator we have 9. We have 9 on both sides of the denominator of this expression equation. Therefore, we multiplied this equation by 9 in order to cancel the denominator 9. So after we multiplied the equation by 9, we have to leave 10 times 70. This equals to 20 minus 3 Qm times 50. Here we divided this equation by 10 and found out that 10 over 10 is 1. So in this side of the equation we have to leave 70. This equals to 20 minus 3 Qm times 50. And 50 over 10 is 5. So in total we found out that 70 equals to 20 minus 3 Qm times 5. Here we open the brackets on this side of the equation and found out that 70 equals to 20 times 5 is 100 and minus 3 Qm times 50 is minus 15 Qm. So in conclusion we found out that 70 equals to 100 minus 15 Qm. Here we subtract 70 from this equation and found out that 70 minus 70 is 0 and it equals to 100 minus 70 is 30. So in conclusion we found out that 0 equals to 30 minus 15 Qm. Here we added 15 Qm to this equation and finally found out that 15 Qm equals to 30. Here we divided this equation by 15 and finally found out that Qm equals to 2 units in itself. This line segment Qm equals to 2 units in itself. Our mission is to find out the length of this line segment AM is equal to x according to what is given as the equation. Repeat again, we have to find out the length of line segment AM that is equal to x. From the domain itself, it is very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. Repeat again, AM equals to AQ plus QM. AQ is 10 and QM is 2. Repeat again. AQ is 10 and QM is 2. So in total AM equals to 10 plus 2, that is 12. So conclusion found out that X is equals to AM is equals to 12 units in its length. Okay, thank you very much.